All right, today we're going to work two additional tension problems and then work an assignment. So here they are. We have a picture of a bag that is hanging between the middle of a clothesline. Both the angles, which is kind of an easier problem, are the same, 3.5 degrees. Find the tension force. So the first thing we do whenever we have a problem that involves forces is we draw a free body diagram. Now I'm going to exaggerate this angle, which we know is 3.5. And because that angle is the same on both sides, I happen to know that the tensions are the same. The weight is pulling downward. That it happens to be the same as force of gravity, which is, I'm going to use 10 to make my life easier for G. So I'm going to estimate G as approximately 10 instead of 9.8. So I know that the weight is equal to 18 newtons. So we need to break these tensions into their components. So we have Tx times the cosine of 3.5 degrees. And then we have on the y location, T in the y times, I'm sorry, that is Tx in the is equal to T, the hypotenuse, times the cosine of 3.5 degrees. T in the y direction is equal to T times the sine of 3.5 degrees. And then we also have another one over here from the second line. So we have another T sine of 3.5 degrees. And that's from the second line. Okay, and then in the x direction, we have Tx equals the hypotenuse times cosine of 3.5 degrees. Now, this is an equilibrium, which means that the acceleration is zero. I've been asked to solve for t. I'm going to focus only on the y direction since I really only have one unknown, which is t. Sum of the forces in the y direction equals mass times acceleration in the y direction. Acceleration is zero, so all my forces in the y direction have to equal zero. So what forces do I have in the y direction? Well, I have t sine 3.5. I have another t sine 3.5, and I'm going to subtract the weight, which is in newtons, and that all has to equal zero. And so we will solve this equation. So I end up with t, I'm going to say 2t sine 3.5 degrees equals w, and I solve for t. So t equals the weight of the object divided by 2 divided by sine of 3.5 degrees. I plug in all my values, which is 18, 2 times sine of 3.5 degrees, and I find the tension in both those lines to be equal to 150 newtons. So the procedure that we use is very similar. We basically draw a free body diagram, we sum the forces in the y direction, and we sum the forces in the x direction. We're going to do another problem. These are not the same. The angles are different, so I know they're not the same. Okay, this happens to also be 37 degrees, and I'm going to use that orientation because I think it's a little bit easier to see. 37 degrees. So I can break T2 into its components. So that's the x, t and the T2 in the x direction. Okay, T2 in the x direction is equal to T2 times cosine of 37. And T2 in the y direction is T2 sine of 37 degrees. And I have the gentleman's mass, or times the acceleration due to gravity, of 600 newtons pulling downward. Okay, now we have two unknowns now. We have T1 and T2. So we actually have to use both the x and the y to solve. So system of equations, two unknowns. So I'm going to first sum everything in the x direction equals mass times acceleration in the x direction. It's not accelerating, so the sum of all the forces has to equal 0. So I'm going to keep track of which we're going to assume to the right is positive and to the left is negative. So what is positive in the x direction is T2 cosine of 37 degrees. And then what is negative in the x direction? T1. And all of that has to equal 0. So we find that T1 is equal to T2 times cosine of 37 degrees. All right, now let's sum the forces in the y direction. All of them have to equal the mass times the acceleration in the y direction. The y direction is not accelerating, so we now have the forces in the y direction all added up. We have two forces in the y direction. One's pointing up, so that's going to be T2 sine of 37 degrees. One's pointing down, which is 600 newtons, and that has to equal 0. So T2 equals 600 divided by sine of 37 degrees. Let's see if I did that already. No, I didn't do that. So let's calculate that real quick. $600 divided by sine of 37. That is equal to 900, I'll say 97 newtons. Now that I know T2, I can use that information and plug it back into the equation that we got up top, and I can find T1. So I now know that T1 is equal to 997 times cosine of 37 degrees. Okay. So these are a little bit more advanced problems, but something that you should get exposed to. And there you go. There's T1 and T2. We have solved the problem.